Hello everyone. This is Dr. Sandeep Singh. I'm working as assistant professor in Khalsa College of Engineering and Technology, Amritsar. So today we are here to discuss a very prompt topic in the field of mechanical engineering, which is engineering materials. So basically, as we all know, we all are surrounded by the things manufactured by mechanical engineering and particularly the materials which are engineered by uh, uh, the mechanical or manufacturing industries. So, in this particular lecture, we will discuss something related to some prompt things which are related to engineering materials. So basically, in this talk, it will be a comprehensive overview of the properties of class regarding classification of the materials and the origin of the engineering materials. So let's discuss the very first thing here. As you can see on the slide, engineering materials are the substances used in the construction of machines, structures, and other products. So basically, engineering materials are those kind of substances which, as we already know, that we are basically surrounded by engineering materials, whether it is wood or metal or non-metal or whatever thing we are using in our day-to-day life. So this presentation will provide us a comprehensive overview of the properties and classification and origin of such materials. Sorry. So basically, the understanding of these particular materials, which allow us to use them appropriately in any kind of application in our day-to-day life. For example, if we are using metals and we know the properties and the things which are related to the metals, so we can appropriately use those metals in uh, more appropriate way and in suitable way. And if we will talk about plastic. So similarly, plastic can be used in the engineering materials as an engineering material uh, in particular fields which are related or where the application of soft parts are required. So basically, the presentation provides a comprehensive overview of the properties and classification and origin of such materials. So understanding these fundamentals is very crucial for particularly for mechanical engineers, but for I must say here for all engineers, whatever or whosoever is related with the industries or manufacturing, for the selection of right material for a particular application. So here we have got the introduction. So in the introduction part, we have the physical, mechanical, chemical properties of engineering materials determine their suitability for different applications. So it is obvious that if we know the physical if we, properties and if we know the mechanical or chemical properties of the engineering materials, then only we will be more confident to apply that particular material in an appropriate way. So the what no what are the physical properties, what are mechanical properties, and what are chemical properties? We will discuss it in the further slides. Like the first one is physical property include density. So density, as we all know, basically it is the mass per unit volume. So similarly, melting point and thermal conductivity. So such kind of properties are the physical are come under the section of physical properties of engineering materials. Then we have got the mechanical properties, which include strength. We all know the strength aspect, as we have typically a dedicated subject related to this property, which is strength of materials in the mechanical engineering or in the field of mechanical engineering. So the second property is toughness. So and the third one is here for just for the sake of example is third one is hardness. So basically hardness is nothing but the property of the material to resist penetration. Like for example, a very common question that has been asked in various exams of subdivisional officers and subdivisional engineers and junior engineers as well. So it's a very basic question which has been asked in the exams is basically that which is more harder, which material is more harder, a glass or a wood. So generally, or it may be any other example as well. So in generally, the students may opt for the property, may opt for the decision that wood is much harder than the glass. So basically, it is not. It is a wrong choice, and that means what material is hard, which material is harder than the other. Basically, it stands with the ability to resist penetration. So if the material is penetrating on the surface of something, and other material is resisting this particular thing to penetrate in between. So the material glass actually resist that particular the other things or the external things to get penetrated in its surface. So glass is basically much harder than wood or any other metal. Yes, the strength aspect is different. So toughness aspect is different. So hardness is the property, this particular property which we have discussed just now. So the other one is chemical property. Now the chemical properties may include reactivity, corrosion resistance, so such kind of things. So, in the next slide, what we can see here, the classification of engineering materials. So, the engineering materials can be classified into metals, polymers, ceramics, composites. Now, what are metals? We are already aware about it. Now, what are polymers? Where polymers are nothing but the types of plastics or types of the polymers. So, in the third example or the third type classification may be ceramics. We all are aware of these things. Ceramics are nothing but the tiles which we use in our domestic use, and it may be wash basins, it may be toilet seats. So all those things are basically manufactured from ceramics, and we do have composites as well. So composites material basically are nothing but the mixture of these things. So metals are here. Metals are strong and ductile, while polymers are lightweight and flexible. Similarly, ceramics are hard and brittle, while composites are a combination of two or more materials with unique properties. So if we want flexibility and hardness both thing, we can mix two materials, so that becomes a composite material. So further moving on in the classification of materials. So we have got in the section of metals, we have got ferrous metals and non-ferrous metals. Similarly, in the section of polymers, we have got thermoplast and thermosetting plast. The switchboards which we are using in our household devices, and the other things which the plastics which we are using in the car's interior. So all those things are made up of polymers. So basically they might be from thermoplast or thermosetting plastics things. So the third one is ceramics and composites, as we have already discussed about it. Now, coming to the next, mechanical properties. Let's discuss something much more detail about these properties. uh, Mechanical properties. In mechanical properties we have got strength. Now strength is basically nothing but the ability to resist rupture, so resist failure. So it is basically the property where the material can withstand to particular forces without getting failure. So hardness, as we have already discussed, that hardness is nothing but the ability to resist penetration. So toughness is basically to withstand with the external forces. Toughness is basically nothing but the to withstand or to withstand with the deformation of those forces which are making some kind of deformation in the material. So similarly, ductility is nothing but the property of the materials through by virtue of which it can be beaten into, it can be drawn into wires. So similarly, brittleness is the property that it in that this particular property, material cannot be break down, material cannot be broke down, but yes, it can be shattered if we use hammer on it. Otherwise it cannot be beaten into sheets, or it cannot be beaten into wires. So in the very next property, we have got thermal properties, where thermal property is melting point. Now we all are aware that what is melting point here. Similarly, conductivity, that the how much the heat carrying capacity of the material, that particular material is basically the thermal conductivity. For example, copper is more has got higher thermal conductivity than any other material. Particularly if we compare it with the aluminium or other thing. Similarly, coefficient of thermal expansion. So in the next part, as we can see here, chemical properties of the material. So before discussing chemical properties, let's have a look on the electrical properties of the materials as well. So conductivity, we have got in electrical properties. The first property is conductivity, and the second one is resistivity. Then similarly, further moving on, in the chemical properties, we have got corrosion resistance and reactivity with the acids. Basically, reactivity with the acids or bases is the property by virtue of which it withstands or it doesn't react with the different type of acids or different type of bases. So we have got the testing and characterization of materials as well, as we can test whenever we make a finalized product in this particular area, we use the testing of the materials, and we have got various types of testing here as well in the field of mechanical engineering, or in the field of manufacturing engineering. The very first testing is the mechanical testing. Then we have got the tensile testing, then the compression testing, hardness testing, non-destructive testing. Non-destructive testing means that where we don't destroy the product which we are testing. So basically, uh, in non-destructive type of testing, we generally don't destroy the product. So ultrasonic testing, whenever we want to check the voids in between the metals or any kind of plates, so we can use ultrasonic testing. So similarly, we have got X-ray testing as well, scopic examinations as well, optical microscopic as well, and scanning electron microscopy. So this is most common among the researchers of PhD students, among the PhD students of mechanical engineering. So this is very common. Scanning electron microscopy is very common kind of testing in the field of mechanical engineering. So here we have got the common engineering materials and their applications. Let's first discuss or first see at the metals, steel, and medium metals. What are metals? We will see the examples. Metals are steels, aluminum, copper, titanium. Similarly, polymers are polythene, polypropane, polystyrene. So in ceramics we have got alumina, silicon carbide. Alumina is basically a polishing agent. So whenever we polish some metal, or we used to polish diamond or something like that, we use alumina as a polishing agent. So similarly, we have got composites, where we have got carbon fiber reinforced polymers, glass fiber reinforced polymers. So in something like that. So material selection in engineering design. Basically, uh, the factors influencing what are the factors that influence the material selection in mechanical engineering. So basically, it is the mechanical requirements. It must be based on mechanical requirements. It must be based on environmental conditions. So definitely, the cost is the major aspect which we will consider in this particular area. Then we have got availability. Then we have got manufacturing process. What kind of manufacturing process we can use to make our final finished product. So material selection process and case studies on the mechanical on the materials in sections is also a very important aspect in the field of engineering materials. So advancement and future trends in engineering materials are nanomaterials, biomaterials, smart materials. Smart materials are nothing but some kind of such as they have the shared memories. They can retain their original shape from under which circumstances they are originally made. So they have got the shape memory, we can say. Or then we have got sustainable materials, additive manufacturing, and 3D printing in material development. Now, in conclusion part, what we will discuss here, we can discuss the what is the significance of the material in order to use these particular materials. So we can say that the importance of the material in now, as we can see here from the next slide, that it has got various metals, ceramics, and other polymers, etc. Now, if we will go to the detail of this particular group, where we can see that metals are comes into the category of material. In this group particularly, uh, the materials in this group particularly is one of the more metallic elements such as iron, copper, aluminium, titanium, gold, nickel, and often other non-metals metallic elements such as carbon, nitrogen, oxygen in relatively small amount. So these kind of things are present in the metals. Now, similarly, we will talk about the atoms in metals, and their alloys are engaged in a very orderly manner. In another case, we can see that in comparison to the ceramics and polymers, metals are relatively dense. So these are the dense materials. Compared to the mechanical properties relatively stiff, particularly in case of metals, they are basically relatively stiff and strong and ductile. So in this particular say, we can say it has got more resistance to fracture. So other properties may include that metallic materials have large amount of non-localized ion electrons, and these electrons are not bound to the particular atoms. Many properties of metals are directly attributable to these electrons. So, in another way, we can see that examples. For example, we can take one example. The metals are extremely good conductor of electricity and heat, and are not transparent or too visible to light. A polished metal surface, however, can have a lustrous appearance. So it has got a luster, where we can say this particular property can be present in the metals. So some metals, for example, copper, nickel, and iron, have desirable magnetic properties as well. So these are the things are associated with metals. Now let's come to the another point in this slide, which is uh, which is ceramics. Now, ceramics are nothing but, just a minute. Ceramic are the compounds between metallic and non-metallic elements, and they are mostly frequent oxides of nitrates and carbides. So, For example, the very common example we can see here, that say here that is aluminium oxide, or we can say alumina, as I told you earlier in this particular discussion or lecture, you can say. So alumina is nothing but a polishing agent we generally use in the polishing of the metals. So it basically what it does, it basically removes all the impurities from the metals. The second example for the ceramic materials can be silicon dioxide. So silicon dioxide is also a cleaning agent, we can say. Then we have got traditional ceramic example, for example, clay materials, porcelain, cement, glass. So these are the ceramics, traditional ceramic material, glass we use in our daily life. We have got the uses of this particular material. Then we definitely use cement in the household hold appliances, or while building our houses, we use cement. Then porcelain is nothing but the bathroom tiles, especially but which we use, not the vitreous one, but the non-vitreous one. And those tiles are have the porosity. I mean, they can absorb water. And porcelain tiles are generally used in the bathroom sides, or the if you have checked the walls of your it can be used on the walls, so it can be used as wall tiles, particularly not the ground walls, but on the wall side. So properties can be ceramic materials have got the properties like relatively stiff and strong, and it has got more stiffness, more strength as compared to the metals. They are very hard, extremely brittle. Hardness is the property I already told you many times, that hardness is the property by virtue of which it withstands the penetration. So we cannot penetrate if the material is hard, we cannot penetrate anything into it. So this property is the hardness. And definitely porcelain is very brittle. It can break if we hit it with some force. That means if it is brittle, then definitely it lacks the impurity. Sorry, it lacks the property of ductility. So it has got various thermal properties and electrical properties as well. It is very insulative to the passage of heat, and low electrical conductivities, and more resistance to high temperatures. So optical characteristics may include that ceramics may be transparent and or opaque or translucent. So in this way, let's come to the another point in this, or the last point of this slide, which is uh, composites. So composites are nothing but the composite is composed of two or more individual materials, which come from the category discussed above. As I told you, the categories the above in this slide, we can see that metals, ceramics, and polymers. So the composites may include two or more individual materials from the above one. So it may be the mixture of metal and ceramics, it may be the mixture of metal and polymers, or it may be the mixture or combination of all three in a complete set. So objective, what is why we use composite materials? The objective to achieve this combination of the property is basically that some kind of properties we require in particular engineering material or for any engineering purpose. So one single metal or one single individual material cannot exhibit all the desired properties. So we need to mix or two or three different materials, individual materials, in one composite. So it may behave the same way as we desire in a particular thing. Okay. So example can be the cemented carbides, which can work as binders to many in the engineering purpose. So it may be the plastic molding compounds containing fillers. So rubber mixed with carbon black can be used in the various machines and various engineering automobile sector. So it can be a wood or a natural composite. I can say as distinguished from a synthesized composite. So it can be a compressed wood. So advanced material we can say here. I must tell you that materials are utilized in the high technological application are sometimes terms advanced materials. So these kind of things we can say that in such a way we have got several and varieties of engineering materials. Now coming to this particular section, if I'll say here, what factors actually influence the material selection. So the factors we will see the factors particularly that are actually influencing the selection of the material is basically the first one is so it can be a mechanical requirement. What kind of requirements we do have in the sector of mechanical field. Then it may be the environmental condition, in which environmental condition, under which environmental condition we are using this particular sector, this particular. Just a minute. I think I'm having a little bit problem with the camera. Just a moment, please. So the next possible reason why while selecting a mechanical or material is the availability, that whether it is abundantly available for that particular purpose or not. So definitely the manufacturing process, whichever process we are actually going to use it while making our finalized finished product. So this can be the influencing factor for a material selection as well. So in this particular section we have seen this thing, and let's come to the next slide. So in this view we can see that there are kind of. Now, talking about the advancements and future trends in the engineering materials, if you will see that nanomaterials are the future scope of this particular section of mechanical engineering. Then we have got biomaterials. Then we have got smart materials. Smart materials such as some materials in this particular section, which may include the combination of nickel and nickel and uh, nickel and titanium. So these the combination of these particular two different elements metals uh, will uh, will exhibit a new form of material, and it is generally known as nitinol. So nitinol is a material which has got the shape memory, so it can memorize the shape. Definitely, if we'll go further, we can see that it is nothing but the transformation of from one phase to another. So transformation of austenite to martensite or martensite to austenite. So it will be the two-way transformation for this particular material, and that comes under smart materials. So in this particular section, we can say that smart materials are, for example, materials we use in fiber optics, spacecraft and aircraft, rockets, shape memory, as I told you, piezoelectric ceramics, so magnetostrictive materials, optical fibers. So these kind of things are basically will be used. These kind of materials will be used in the upcoming years. So we can say that it has got very bright future. This particular section has got very bright future in the upcoming years. So what we will see here, that what are the common questions that a student may ask from these particular slide, as we discussed. So what are the smart materials? As I told you, that smart materials are nothing but the it has got different it can exhibit different kind of properties under different circumstances. So such as it has got shape memories, materials, that it can memorize one type of shape. Even if we will stretch it in certain way, or if we will deform in a such a way, but it has the capability to memorize its original shape, how it was actually formed. So in this particular say, we can check the different kind of properties. Do we have examples of smart materials in real time? Yes, we do have. As I told you, Nitty coal is the very famous or very well known example for this particular material. Nitinol is the nitinol is nothing but the example of smart material. So another way here, we can see the smart materials are the materials that can change their property in response to external stimuli such as temperature, light, pressure, electrical or magnetic fields, or another way pH values, and etc. So these materials have unique characteristics that make them highly useful in various engineering and technological applications. So another example, as I told you here, the shape memories alloys. Shape memories alloys are metallic material and that can return to original shape after being deformed when it has been subjected to a change in temperature or stress. So one common example is nitinol, which is a nickel and titanium alloy. So in short, if I do a quick revision what we have done till now. So under a quick revision, I will discuss it with you, with the students in this discussion, such as the material science. We just have talked about material science, and material science is nothing but the investigating a relationship between, or that exists between, the structure and properties of material. So investigating the relationship between structure and properties of material. Another example of materials engineering, or can be taken as, or a definition can be taken as, on the basis of these structure properties correlation, designing or engineering the structure of the material to produce predetermined set of properties. So we can change the material properties as per our requirement in this particular science. So practically it is possible to change a particular set of material to our desired combination, or our desired set of properties. So we have studied structure here. The structure, what is structure? Structure is basically arrangement of its internal component, how the metal is actually prepared, or how the material is actually made up of. So it can be the arrangement of atoms as well. It can be the arrangement or structure of the space lattice as well. It can be the APF factor, atomic packing factor. So there are several kind of things we can discover in this particular science regarding material. So further, we have discussed different kind of materials, classification of materials we have done here, such as metals, ceramics, polymers. So in this particular materials, such as iron, aluminum, copper, and titanium, and gold and nickel. So these are the metallic compound, or metallic elements. and other one is non-metallic elements such as carbon, nitrogen, and oxygen. So in this particular way, we can say that these material can be used to have desired can be used, or the properties of these materials can be enhanced as per our requirement. So in another way, the ceramics material, as we have already studied, that it can be a clay minerals such as porcelain. So porcelain basically can be used in our daily routine life. In terms of tiles, we use, or it's a very common example. That's why I'm saying it again. So it may be cement, or it may be a glass. So these are basically traditional ceramics, you can see. So then we have talked about the polymers. So polymers are nothing but the carbon-based compounds, where we use carbon as a main element. So in this particular, say, the polymers may include the familiar plastic or rubberized material or rubber material. So where the carbon is in high content, or the main component. So many of them are organic compound, and they are generally based off of carbon, hydrogen, and other non-metallic elements. So in another way, we have studied the composites as well, which is the combination of these above three, the metal, ceramics, and polymers. So it may be the combination of these three things: metal, ceramics, and polymers. So what is the objective of this particular composite material? So it may exhibit desired properties of all three, so we can selectively choose those particular material as per our requirement, if it is being used or being applied in the engineering sector. So definitely we have studied advanced materials here as well. So advanced materials are where we use high-tech applications, such as, we can say that materials that are utilized in high technology or high-tech applications are sometimes termed as advanced materials. For example, military or rocketry materials. We use a different kind of fiber optic systems. We use different liquid color crystal displays in another household appliances. Then we have got fiber optics. We are using that kind of fiber optics wire in our broadband services as well. So these kind of materials can be studied further to know more about the materials. We will discuss it in the further lectures as well. So another way is biomaterials are now have got gained the high demand in this particular sector, and the biomaterials are nothing but the biomaterials are employed in component implanted into the human body for replacement of any damaged body part. You may have heard in the various sectors of medical field that this material or the bones can be transferred by the metallic bones. So if a particular bone is fractured, so doctors can replace that bone with a metallic one. So that kind of materials are known as biomaterials. So actually we generally implant those kind of materials in the body, so that they don't harm to the human body, and they don't react with the blood cells or the tissues with the or tissues of the body. So they must be accommodated in the body, or they must be acceptable in the human body. So then we have got the selection, the semiconductors as well. Now, semiconductors materials that have got electrical properties that are intermediate between electrical conductors and insulator. So, semiconductors means they will exhibit the both properties. So, the electrical as well as insulators properties. So, in electricals, it may have metal or metal alloys. So, these are the electrical conductors particularly. And in case of insulators, we can say the ceramics and polymers are basically insulators. So these kind of things we can study in this particular stream, which we will discuss in the further lectures. So we will definitely study regarding the defects in the solids as well, and we will study some kind of defects such as point defects, line defects, volume defects, and so that it may provide us the proper understanding of this particular field. So I think these are the things that we need to know for the basics of this particular topic, which is engineering materials. So it is a small kind of try, or a small effort to make a general discussion, to make this lecture possibly understandable for the engineering students who are new to this particular field. So I hope you like this lecture, and you will learn. You might have learned something from it. Uh, we will meet in the next lecture in the same field, and we will discuss the further properties. Thank you.